transition line increases, the crosstalk, the strength of a energy coupled will be less, which is something inversely proportional. So as distance between these two traces goes up, the strength of crosstalks come down. So right now, let me configure from, let's say, sweeping from 6 mils to, let's say, I have option of sweeping to 18 mils, having increment of each 2 mils, separation of 2 mils. That will represent almost 7 counts, 7 type of variation in signal. Run sweep, erase all the old data, start sweep. So let's first try to evaluate our U3, which is a near and crosstalk. And when I go back and expand this cursor, I can see that at 6 mils, okay, we have already seen the situation of 6 mils. Let me take minimum first and maximum. Only two values we'll try to measure. So this is close to 137 millivolt. At near end, when the distance between these two transmission lines are 6 mil, and when the distance between transmission line is 18 mil, the voltage has significantly reduced by 47.65 millivolt. Same goes for the far end crosstalk. So let me only take care of maximum distance. Okay, let me first calculate minimum. The minimum would be somewhere close to 287 millivolt, wherein in the longest distance between these two, the crosstalk at far end would be 96 millivolt. But making these changes may not be possible every time. That means we cannot have a clearance between component of order of 18 mil, which is something very huge. So people tend to take extra care by having, when we are talking specifically of high speed traces, so it is not applicable to all the signals. It is something which where the edge rates are very high. So for those signals, I would be placing a shield, maybe a ground shield, something of this sort. So if you have to avoid these situations inside your PCB for some of your critical signals, which says that the induced energy in a victim net is not, it is significantly high. That means it's order of volts instead of millivolt. It's a volt, right? So maybe my design will have acceptance of crosstalk between signals in the order of, let's say, maximum of 150 millivolt. So I say that the crosstalk which is induced in a victim net, if it is order of 150 millivolt, I should be happy because the ICs which are connected to the victim nets may not really influence or may not trigger anything, right? But if it is something which is greater than 150 millivolt or equal to, I should be really worried about that. Now, how do we solve these challenges, right? The one way of doing is that if you have a possibility, you can simply increase the distance between them. But if you do not have such conditions, then what you can do is you can take a signal, place a guard trace which is reference to ground, okay, and then you can have this. So most of the energy will be directly coupled to the ground, okay. So when this guy is switching, it will couple energy to ground, not to the victim net. Okay, most of the energy will be coupled, and when this guy is switching, it will now couple to ground. So it is also possible that in a condition both are switching and exchanging the magnetic and electric fields between them. Okay, so crosstalk, I have done the demonstration. I wanted to work with timing parameters, how it influences your setup and hold time requirement. but this would take a little more time because I also have a DDR in place showing what are the challenges in DDR. Okay, and I'm not sure if we have already exceeded our time limits in this case as well. So there are many more condition need to be. There are many more slides left. Okay, in terms of uh, so we are left with topic called DDR solution in hyperlinks, and we are about to see uh, timing analysis or timing challenges, which basically comes with signal speed challenges. But okay.
Manoj, what about tomorrow? It can be covered in 1 hour.
Mm, maybe if we can, what we can do is we will try to. Okay, we have already connected two sessions, including today's session. So what we will do is we'll try to announce one more sessions which will cover the missing parts of these webinars. The first webinar we had missed something called PGN analysis and AC analysis in a power integrity form, and today's seminar we supposed to cover DDR analysis as well. So those two we can club and maybe we can have one common webinar. If it is,
Hey, hello. Hey, Manoj, this is Manmohan.
yes, please.
Yeah, whatever the topics you have covered, you covered already almost whatever the scenarios used in the industry right now. I do have one more request regarding the differential pair simulation.
Okay.
Uh, we are working in optical fiber industry, and we do have the simulation of 10 gig, 25 gig
Hmm.
data rate on the electrical side. So is it possible to have a little bit briefing on the differential pair simulation, maybe on 5 gig or 10 gig, whatever you have that matter?
Sure, we can surely look into such requirements wherein we can specific to differential pairs. But as you shared, you're working with high speed, right? In order
Yes.
of 10 gigahertz.
Yes.
10 gigahertz is something will
Mm-hmm.
requires lots of advanced
Yeah.
understanding of electromagnetic field, as well as
Yes.
there are no 2D solvers which
Mm-hmm.
can give you more closer practical results
Mm-hmm.
simulations. You'll have to talk
Yes.
about 3D simulations,
Yeah,
which are
we generally use a CST simulation, not that hyperlinks, but we are seeing some opportunity to change the software if everything is available with hyperlinks.
so for such. Okay, first thing to understand thing, anything goes above 2 gigahertz or 3 gigahertz of signal bandwidth, your
Mm-hmm.
2D solvers will not be able to capture a realistic information, or maybe it is not be able to capture the transmission line model properly. Okay.
Mm-hmm.
To do
Mm-hmm.
so, we recommend that anything above 3 gigahertz need to be taken care by in a 3D environment, which can be either FTTD solutions or FEN solutions,
Mm-hmm.
or hyperlink something have a hybrid solutions, which basically works on MOM principle, which is known as hyperlinks advanced solvers.
Okay.
Okay, so we'll have to introduce that part. That is very interesting topic, and I think
Mm-hmm.
I can really make a note of that and try to include some presence of that also.
Yeah, sure. Because I'm also a beginner in this field, so I never use so much simulation. But based on the experience and what are the boards we are doing, so based on that experience we are doing. But we do not have such a specific tool. I didn't work on that, but my seniors they are using CST simulation for that one. That is
Okay,
not available in India right now. So we do have some kind of global team. They are using that CST.
okay,
So,
okay.
so need to understand the things as a beginner, not in very the expert level. I am also a beginner on that particular level.
Okay, surely. Maybe, as you rightly suggested, it is a really good idea to involve 3D simulations.
Mm-hmm.
Also, try to present a case study which displays that the difference between 2D solver and 3D solver.